Alright, so today we're going to be looking at a new equation. We'll be looking at something called Boyle's Law. Uh, so we just finished up gas stoichiometry, being able to look at chemical reactions that create gases and predicting the volume that will be made. Today we're going to be looking at, if we're looking at just a container of gas, and it doesn't even have to be a pure gas, it doesn't have to be pure oxygen or pure helium or anything like that. It could be a mixture, just like what we have in our atmosphere and the air we breathe. It's a mixture of nitrogen, oxygen, hydrogen, helium, carbon dioxide, carbon monoxide. It's very, very much not pure. But there are some interesting relationships we're able to see. So way back in the day, a researcher with the last name of Boyle, he looked at the relationship between pressure and volume. And what he found is that they are inversely proportional. So if you increase pressure, you decrease volume. And it increases and decreases according to a set relationship. We can very accurately predict how these two values change according to each other. All right, so what we see here, Boyle's Law, the equation we're going to be using to predict these changes is P1 V1, or starting pressure times starting volume, equals ending pressure times ending volume. So the P just stands for our pressure. Now generally we'll be using two different units for pressure. You can see either one. We can see atmospheres or we can see kilopascals, so ATM or kPa. And so long as the pressures are the same on both sides, not a problem. I will always give you the same pressure on both sides. Or if we're looking for pressure, we just have to make sure that it matches the pressure that's already there. V is in volume. We just measure that in liters. You can use milliliters. It doesn't really affect your equation at all, but you might want to convert it into liters. So then the ones and the two. So what does that stand for? So anything with that little subscripted 1, that just tells you that's your starting value for that variable. So P1 is our starting pressure. V1 is our starting volume. That little subscripted 2, that tells us that's our ending value. So P2 is our ending pressure. V2 is our ending volume. The way that these work is we're always going to have 3 of these values, and then it's just algebra to figure out what the 4th one is. Alright, so let's take a look at that's not what I wanted. That's a little bit better. Alright, let's take a look at a practice problem quick. That up to about there. There we go. Put that down here. Alright, so down here it says a scuba tank has a pressure of 190.5 atmospheres and a volume of 10.3 liters. What would be the, probably make that bigger. Alright. So what would be the pressure of the gas if it were transferred to a 50-liter container? Alright. First thing I would suggest we do is, alright. Let's actually figure out what these values are. Alright, so starting off with, a scuba tank has a pressure of 190.5 atmospheres. Alright, that's our starting pressure. That's going to be our Q1, so 190.5 atmospheres. Alright, and a volume of 10.3 liters. Alright, so that's our V1. Alright, they then say what would be the pressure of the gas if it were transferred to what would be the pressure if it were transferred to a 50-liter container? Alright, so we said what would be the pressure. That's our P2, that's what I'm looking for. And then volume 2, they said is 50 liters. Alright, so now I've got the 4 variables. I figured out which one I'm looking for, so now I just need to put these numbers up into this equation here. Alright, so where I see P1, I'm going to put 190.5 atmospheres. times V1, which is 10.3 liters. That equals P2 is what I'm looking for, so I can just leave that P2. If you want to do the algebra and make that your X, that's fine as well. And that's times V2, which is 50 liters. So, alright, so now I've got 190.5 times 10.3 equals P2 times 50 liters. Alright, so now in algebra, how would you get P2 by itself if it's being multiplied by 50 liters? You do the opposite. And what you do to one side, you do to the other. So on both sides, we need to divide by 50 liters. 50 liters. Alright, so now that cancels that. And now we can also do some unit analysis. I have liters here and here. So those liters are going to cancel out. That means the unit I'm left with is atmosphere, which is the unit for pressure. Alright, so now I have that here. I have P2 equals 190.5 atmospheres times 10.3 over times all over 50. Alright, now I just need to plug this all into the calculator. So 190.5 times 10.3 divided by 50. Alright, so our pressure, the pressure here is 39. There we go. Our pressure here is 39.243. And we said before the only unit we had left was atmospheres. Alright, so now we should be able to look at this and see if it makes sense. So our starting pressure was 190.5 and volume was 50.3. It looks like our volume quintupled in size, so it increased 5 times. And it looks like our pressure pretty much decreased by 5 times. So that makes sense. So that's kind of how we can know that our answer does make sense. Alright, let's do one more. Alright, starting off with, I'm just going to put the equation we're using at the top. U1, U1, U2. Alright, so let me scroll down to the next one. This one you do see as well. Alright, so this question says a balloon with a volume of 2 liters is filled with a gas at 3 atmospheres. The pressure is reduced to 0.5 atmospheres without a change in temp. That just means we get to not think about that one at all. What would be the volume of the balloon? Alright, so in this case, I will always begin by listing out the variables P1, V1, P2, and alright. So according to the question, it says a balloon with a volume of 2 liters, that's my starting volume, is filled with a gas at 3 atmospheres. That's my starting pressure. Atmospheres or kilopascals is pressure. They say that the pressure is reduced to 0.5 atmospheres. Well, what would be the volume of the balloon? Alright, so we're looking for V2. So I've listed out what they gave me, and I just need to plug those numbers in. So P1 is 3 atmospheres. That's times V1, which is 2 liters. That equals P2, which is 0.5 atmospheres. Times V2, and since that's what we're looking for, just gotta leave it V2. So I've got 3 atmospheres times 2 liters equals 0.5 atmospheres times V2. Now, I just got to get V2 by itself, so 0.5 atmospheres times V2. Algebra, we know that we just need to do the opposite of what's happening to it. We do to one side, we do to both sides. So the opposite of multiplying by 0.5 atmospheres is divide by 0.5 atmospheres. Alright, so let's get rid of U and U. So now we have V2 is equal to, oh wait, atmosphere is here, let's cross this out so the units are away. Alright, so V2 is equal to 3 times 2 liters all over 0.5. Alright, so really I've got 6 liters over 0.5. Alright, so 6 divided by 0.5 should give me 12. Alright, the answer for this problem, if I'm uncertain, equals 12, and the only unit we have left once again is liters. Alright, the good thing about these gas laws is that they're basic algebra stuff. They're just solving for one variable. So it's just about doing the opposite of what's happening to the variable. That should help out. And with that, good luck.